Hi guys, today we're going to finish learning the names of the polyatomics and the charges that go along with those polyatomic ions, and then we're going to do some example problems to learn how to name and write formulas using the polyatomics. So I want to start with page 2 of the notes that I gave you the other day, and we're going to start with manganese, the manganese section there that I just highlighted in blue. So the first one there, MnO4, that has a -1 charge, we call that permanganate. And I want to remind you that the ions, the whole group, the MnO4, that whole grouping has a negative charge. That negative charge is not just on the oxygen. The next set of polyatomics that we have are chromate and dichromate. Di means 2, so you can see in the dichromate you have Cr2, and in just chromate you have 1 Cr. So this is chromate, and then this is dichromate. Notice that they both have a -2 charge on the ion, on the polyatomic ion. And then the last one in this set is called cyanide, Cn-. It has a -1 charge, and the name of that one is called cyanide. Now I'm going to move down to the chlorates, and I have the chlorates, I just kind of put a little block around them in purple, and I'm going to name them, and we're going to do the notes off to the side and fill in the blanks there. So the first one, ClO3-, that is called chlorate. These all have a -1 charge, but they all have different numbers of oxygens. So perchlorate means that we added an oxygen. So I have ClO4, again still a -1 charge. Then I have chlorite, and remember, nitrate, nitrite, sulfate, sulfite. When I had one less oxygen, I had the ITE ending. So ClO2 is one less oxygen than chlorate, ClO3. So it has 2 oxygens and an ITE ending. Still a -1 charge. And then I have hypochlorite. Hypochlorite is an ingredient in bleach. So maybe your mom or you use bleach to whiten your clothes. It would have this hypochlorite, sodium hypochlorite, chlorite in the ingredients. So let's take a look at the notes off to the right-hand side there. Per means there is one more oxygen than the 8 ion. And I mentioned that chlorate to perchlorate, I go from O3 to O4. So per means I have more oxygen. And hypo means I have one less than the ite ion. So 2 down to 1 oxygen. So those are our chlorates. And now we'll look at our phosphates. That would be these right here in green, and I'm going to write them in green as well. PO4 has a -3 charge, and this is what we call phosphate. And then I've added a hydrogen to the PO4. That means the charge goes down 1, so I have -2. So this would be hydrogen phosphate. I think it'll be hard to get all in that one line for you guys too. And then H2PO4 would be dihydrogen because I have 2 hydrogens. Notice the charge went down to -1 because now I have added 2 hydrogens, and we still have a phosphate attached to those hydrogens. So phosphate, no hydrogens, hydrogen phosphate, 1 hydrogen, the charge goes to -2, and dihydrogen phosphate, 2 hydrogens, the charge goes to -1. And I think now that we have covered all of the polyatomics that are on the right-hand side. Now on the left-hand side are the positive ions, and there's actually two of the positive ones that I want to cover all the way at the bottom of the notes, NH4 plus and H3O plus. So these would be positive polyatomics. NH4 plus is ammonium, and H3O plus is hydronium. Now I think that you could fill in the rest of the right-hand side based on naming monatomic ions that we did in class. A couple that I'm going to highlight, I'll do them in pink, would be zinc, because it's always a +2, silver, because it's always +1, nickel, because even though it's in the transition metals, most times it's a +2, and cobalt would be the other one. And these you kind of just have to remember that they're kind of in that transition area. Well, they are in that transition area, but they have the same charge all the time. So these are exceptions to the rule, okay? So you kind of have to remember those. The rest of those I think you could fill in. We probably did some of them in class, or they maybe are on that monatomic ion worksheet that we did last week. So now we're going to practice with these 6 examples that are on the front of this page. So we're going to take a look at number 3, and this one's saying that the name is ammonium nitrate. So I'm right here. Ammonium, if you remember from the ions that we just filled out, ammonium is NH4, and it has a +1 charge. And if you look back on page 2, we did nitrate last time we were together in class, which was Friday, I believe, and that would be NO3 minus. So both of those charges and formulas I got from that paper we just finished filling out. Now you'll notice that I have a +1 charge for the ammonium, a -1 charge for the nitrate, +1 minus 1 equals 0. So I don't need any subscripts here. I just need to write the formula based on the polyatomic ions that are given. So the formula here would be NH4 NO3. Now I do need to keep the subscripts there for the hydrogen and the oxygen. Those do not change when I write the formula. But I don't need any other subscripts for the polyatomic. So NH4 NO3. So let's move down and look at number 5. Number 5 says nickel hydroxide. We know from the charges that we were given that nickel is a +2. And if you look back on your polyatomic sheet, you would see hydroxide is -1. Well, now I have a +2 and a -1, so those aren't equal and they aren't going to equal 0. I need to have 2 hydroxides at a -1 charge to balance out the nickel that is at a +2 charge. So I'm going to end up needing 2 hydroxides. 2 times -1 gives me -2, and when I add that to +2, I get 0. So the formula will be Ni. Now polyatomics, if they have subscripts, I need to put them in parentheses like so, with a little 2 outside. The next one is aluminum carbonate. Aluminum is not a transition metal. Aluminum is in group 13, so it has a charge of +3. Carbonate is a polyatomic ion. You won't find that on your periodic table, but you will find it on your chart in your notes, and that's CO3 2-. So I need to find a common factor between these two charges. I have a +3 and a -2, and my common factor will be 6. So 3 times what gives me 6? Well, we all know that that is 2. if I have a negative 2 charge here, times what gives me negative 6? Well, that's going to be 3. These numbers here, where the arrow is pointing, are your subscripts. So I would be writing this one AL, and I said it has a subscript of 2. And then CO3 is going to have a subscript of 3, because I needed 3 of them to balance out the plus 6 charge of the 2 aluminums. I need to put that carbonate in parentheses with that 3 outside the parentheses. Let's take a look at number 4. 4 is iron 2 sulfate. Now you can see here I have some transition metals. So iron 2 means I have an iron ion with a plus 2 charge, and sulfate is SO4, that's a polyatomic with a minus 2 charge. The more you use these polyatomics, the easier it will become to write them and have them memorized. Again, you don't need to memorize them, but you need to know where to find them on the chart and know what the charges mean. Well, here I have a plus 2 and a minus 2. Well, if I add those together, they equal 0, so I don't need to add any subscripts here. I just need to write the Fe and the SO4, and that would be my formula. Now down here, they're telling us that Fe is plus 3, because I have a Roman numeral of 3 in the name, and sulfate again is SO4 with a minus 2 charge. Oops, minus 2 charge. Now here that common number is 6 between them, so what am I going to multiply by to get the 6? So positive 3 I would be multiplying by 2, negative 2 I'd be multiplying by 3 to get negative 6. So this is again what my subscripts will be for this formula. So Fe2 and then in parentheses SO4 with a 3 outside like so. And the last one is copper 2 perchlorate. Here's one of those chlorates, per meaning I have an extra oxygen on the chlorate, copper 2 meaning that I have a copper 2 ion, so plus 2 is the charge. Perchlorate is ClO4 with a minus charge. Well, I only have one minus 1 charge of ClO4, but I have a plus 2 charge on the copper ion, so I will need 2 perchlorates to balance out the plus 2 charge for copper. So I would write the copper, and then in parentheses, since I need 2 chlorates, I would put a 2 outside the parentheses. So that gives you some examples with quick explanations on how to name with polyatomics. Now, your homework is going to be to complete the polyatomic formative on GoFormative. So you can log in and you can complete that, and that will be due tomorrow in class, and we'll be going over that in class, so please make sure that you have it completed before you come to class on Wednesday. I hope this lesson was informative and you can understand how to name with these polyatomics. Any questions you might have, email me or you can ask on Wednesday. Take care, guys.